Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And in this video today we're going to take a look at some introductory C++ programming problems. So we're going to take a look at the three major steps that are involved in going from problem to solution. So first up, we're going to be figuring out how to get inputs or givens, things from the user or just all the data that we need to set up so that we can actually go to step two, which is of course to process that data and take it from the inputs and then process that output and then literally output the output to the screen when everything is complete and we know we have the answers that we are looking for. So we're going to do 6 different problems here. There we go. So we're going to take a look at 6 different problems of varying difficulties, or just different types of problems here. Let's see what we do. Okay, so one thing to keep in mind here is that I accidentally reversed the A's and the B's, so thank you to the students who have told me that last couple days. So just keep that in mind as you see the code, that everything I believe will turn out correctly. I've just kind of reversed the A's and the B's here. So let's move on to problem 1, where we're going to be integrating from 2 to 3 on the curve here, x dx. So to get this thing started, I'm going to need a main function, and every program needs a main function because that's basically where your program starts running from. And whenever they designed and developed this language way back, that was just what they decided. So there is a main function. It must return an integer value. And in their case, we're going to return a 0. So when this function closes, basically when our program ends, we're going to return a 0. And we're going to return that 0 basically to the operating system or whoever ran this program, telling them that our program executed as we expected it to. And of course, up until we're ready to submit this thing, that might not necessarily be true, but at the end of the day here, we're going to return a 0, indicating all is well. So for the 3 types of events that we're going to be covering here, we have our input stage. We're going to have our process stage, and then we're going to have our output stage. And since I know there's going to be output and we're going to be printing out to the screen, I can include the IO stream. And that's just a file somewhere that contains all the information that we need to basically get input from the user and give output to the user, in this case to the monitor, to the window of the program. Okay, so let's just take a look at just printing something to the screen. So I could do something like this. Hello there, or hello world, or something like this. There's a lot going on here. And so this is saying console out, or cout, print to the screen this string here, which is hello there, and then print an endl or an end line or a new line character, basically telling the prompt to go to the next line. And this doesn't work, or you see compiler errors here, and it says even though we're using the IOStream library, and I told you that all of these things are found in there, you can still see that there are errors, and that's because there's one extra level of protection here when it comes to function calls and things like that in libraries, at least within C++. And that's, just consider if 15 or 20 of us were working on a big project, some kind of project where we're all working together. And your code is your code and my code is my code, but we all have to work together. Just think of how fast would it, how long would it take for one of my variables to conflict with one of yours, or a function name or something like that, where it just goes, well, let's access X. And you're like, well, whose X is it? Is it Brad's? Is it Jim's? Is it Mary's? It's like, well, we can't really resolve that. How would we resolve that? And so the idea is that we can put in what's called a namespace. And then basically we could say, oh, this is Jim's, or this is Mary's, or this is Brad's function. In this case, that name that we're saying here is std. And so basically anytime it sees cout, it goes, oh, here, also look here if you can't find it somewhere in this function, and it can, or I'm sorry, in this file. And so it can find the cout here in the std namespace because the inside of this file, so everybody's happy, and this thing will run. Slow computer tonight. There we go. There's my hello there. And you can see things are working. So we're going to modify this in a couple minutes, but now we're at the input stage. And so in our case, it's not really for problem 1 anyway. It's not really an input, it's more of a given. So I want to make sure I do this right. So let's see, A is the smaller number. If I do this, please, I hope I didn't already talk myself into doing it wrong here. And B is 3.0, because I'm going from 2.0 to 3.0 on my integral. And so those are my two inputs. And I know it's like one of those, you see X, and we always see X, the algebra. We see the algebra for what it is, right? We're like, oh, can we use that? Like, no, it's meant to be a graph, right? So we're not going to have to worry. We have our two inputs for this problem. And we do need to process this because we're going to have to take 1/2 x squared from A to B. So I'm going to say, okay, so the high and the low, the high value and the low value. So the low value of the two here, and I'm just without drawing, I'm sorry, I don't have anything to write that tool out. So I could just say, okay, well, it's x, 1/2, 0.5 times A times A, 1/2 A squared, right? And then on the other end here, it's the same deal here. The high value is going to be equal to 0.5 times B. So those are my values for x, right? And so I have my low and I have my high. So in this case, that is the processing that's going to be going on here. So I just figure out, so what is that going to be? 1/2 times 2 times 2, which is 2 overall, right? 1/2. And then 1/2 of 9 times, or 3 times 3 gets me 9, so 4.5. So 4.5 minus 2 should be, what? We'll figure it out, right? So let's take a look at the output stage here, where, or I guess I could say the result is equal to the high minus the low. And now here at the output stage, instead of saying hello there, I could say something like the result is, and then I can add a little, add the little chevrons here, and then say result. That's all I'm looking for, plus that end line. Now everything should run properly. And let's see what our answer is. That's 2.5. Kind of what I was getting at before my brain just had a fart there when it came to trying to do the math in my head. So 4.5 times 2 minus 2 is 2.5. So there you go. So that is how you would do number 1. And everything kind of follows suit from here, just different problems, just different complexities when it comes to the calculus. Okay, so now looking at problem 5, things are a little different here. The function is going to be 9 times, 9 times x or whatever, that's the integral 9x plus c is the result there. But in this case, instead of having givens, we're going to need the actual inputs from the user. So this is going to be something you do pretty much every time you need an input, at least as you get going here. So I'm going to need a double value from the user. Well, this will be the low value. And so I'll ask basically here with a print statement, I'll be like, here, please enter, or just enter a value for, make sure you just put a space here, it just looks a little better formatted wise. And then do cin with the A. And notice that the little chevrons here go basically from the data to where it needs to get streamed to. So this string is going to get sent to the cout or the console, the window where the program is running. And then I'm going to say console in, get input from the user, and whatever they do, put into the A variable. And I'm just going to do that twice over this time around. Oops, get rid of that. So then enter a value for B, and then C and D. So that will cover the entirety of the input stage for that, because now I have an A value and I have a B value. And so basically this almost stays the same, but remember I just have to change this to 9.0 times, because that's what this integral is asking for. So 9.0 times B, or 9B minus 9A. And then we will get the result here. We can try this out from 0 to 10. Should give me 90, right? And it does. And so from 0 to 9, because that's basically just asking, it's basically just what's, the area 9 times, it's almost like a rectangle, almost a square. Whatever the difference here is, that's the one side of the rectangle, and the other side of the rectangle is 9. So that's, oops, oh, I'm sorry, let me drag this down a little bit. So here's the full program for number 5 with everything that you should have. Okay, so coming back now for number 9, we're kind of back to where we were a minute ago. I can just from here, I can comment this out because we'll use it in a minute. or at least we will, at least part of it. And so we'll say, okay, so this time around my input stage is x is 3, so double x equals 3. So, because it's very specifically telling me that. And the derivative of 5x cubed is 15x squared. So taking that from here, here's my process stage, and say, okay, double result is equal to 15 times x, 15x squared. And so then the result is the result. So this should be printing out what 15x squared is in this case for 3, 935, and it does. All right, so moving on to this guy here, it's just a little more complicated because we need the input from the user instead of just taking a given. We actually need an input, and I can just kind of switch this up real fast here and just say, give me an x value, and I will give me an x value. And in this case, it's just 18 times x, because that's the derivative of 9x squared is 18. So I just, and then now that should run. Let's try it out. So of course, if I put a 10 in here, it should be 180, and it is, just because it's 18 times x. And so that's how you cover up here and finish problem 13. Okay, so moving on here to number 17. So we're back to having an integral from a to b. So I do need to get the information from the user that way. Again, it is reversed, so but I'll do it correct in the end. Just a notation issue, not anything that I did on purpose. So there's my a value and there's my b value from the user, and everything gets put in the right place. And then from here, of course, the integral of 4 sine x is negative 4 cosine x plus c. And we don't have to worry about the plus c part. But we do need to include a separate file where all those extra cool math functions are found. And it's found in a file in a library called CMath. And so you can look up, there's a ton of functions, and they're adding more every so often too that we can use. Like the hypot function is one that I didn't realize existed for a while. It makes figuring out the hypotenuse quite easy. So in this case, negative 4 times the cosine of whatever a is. That will be, I guess, the result. I could say here, this is the, remember from low and high from a minute ago here. So I could say, oh yeah, it's negative 4 times the cosine of whatever a is. And then I could say that the high is the same thing here, just use b. You can see the theme. We already kind of did this problem before when we did the number 5 one. We're just doing a different, we're just using a different integral. And then the result will be equal to whatever the high is minus the low. And then we're going to print that value out. And off the top of my head, I don't have, let's see, from 0 to pi. Let's try it out. 0 to 3.14159265535. I get a value of 8. Is that what I'm expecting? And thank you, Verbo, and thank you, integralcalculator.com, for this answer here. And yes, I am correct. It just did, I don't know what I was expecting, but I was not expecting to see 8. And I just wanted to make sure that I was doing it right, and I am doing it correctly. Everything worked out fine. So here is the code that handles everything there, part of 17. So let's take one final look here at the last problem, number 21, and we can call it a day. Okay, so this problem number 21 then. You can leave the input stage exactly the same since you're asking for the same a and b values as you did a minute ago here for number 17. So that's all good. So now it's just a matter of remembering the integral of secant x tan x. So in this case, the integral of secant x tan x dx is secant x. So this ends up being 5 secant x plus c. So from this, I can say, and you think you could just turn this cosine into an s, for secant, and it actually doesn't work. So you kind of have to go ahead and divide. And in this case, we're going to take the 5 because it's 5, and then we're going to divide it by cosine x. So for whatever reason, you could divine your own. And basically all you're doing is just inverting, right? Cotangent with tangent, cosecant with secant, or cosecant with sine, and secant with cosine. And so it's just a matter of changing things up to 5 divided by, or 5.0, just to be consistent here. So 5.0 divided by either cosine A or cosine B with the result. And in this case, let's see, if I put in 0 and 1, I should get, I don't know the exact value I should get, or if I should know even the exact value, but I get something about 4.254 if I do it right. Yep. Okay. So yes. So I have set everything up properly, and I've basically used all of the appropriate C++ functions for secant and tangent and got everything correctly here just for secant, which is just 1 over cosine. All right, so that covers all of the problems I wanted to cover. You may or may not have some of these, but I definitely wanted to make sure you knew how to do each one of the 6 types that are sitting there for the. So if you have any questions or any misunderstandings here, or definitely if I misspoke about something, it's very possible I misspoke again when dealing with integration, but I think I at least got the numbers right. Let me know. But if any of that, you can always comment below and let me know about that, and I will correct everything as quick as I can. Or you can, of course, email me at swardb@cod.edu, and I will, basically do the same thing. So I hope you have a nice day. Hope you learned a little bit from this video, and have a great day, and I'll see you guys in future videos.